This is IAQradio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus, episode 645. We've got a great show with Dr. Sarah Haines of the University of Toronto. We're calling it The Puzzle of Buildings and Health, Research to Practice. So another great Research to Practice show. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget about the afterthoughts at afterthoughts.iaqradio.com. Join the discussion after the show. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Restoration Industry Association, restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org, Healthy Buildings America 2021, HB 2021-America.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, Grey Wolf Sensing Solutions, GreyWolfSensing.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to Dawn Weeks, Ottawa, Ontario, Canada, who was first to identify LIDAR as the method used for determining variable distance by targeting an object with a laser and measuring the time for the reflected light to return to the receiver. The IQ Radio Trivia question for today, November 12, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IQ investigations at tsi.com. Here's today's IQ Radio Trivia question. Name the winner of one half of a Nobel Prize in physiology who later coined the term microbiota. Back to you, Joe.
All right, so we've got Professor Sarah Haines. Her interdisciplinary research integrates building science, engineering, and microbiology to analyze the impact of the built environment on human health. She uses cutting-edge microbiology techniques such as next-generation sequencing, metatranscriptonomics, and bioinformatics to understand the impact of weatherization and extreme weather events on indoor air quality, particularly in low-income communities who may be at a higher risk for asthma. Her work aids in the understanding of indoor exposures from microorganisms and chemicals, providing for a cleaner and sustainable indoor environment. Her PhD is in environmental science from the Ohio State University. Make sure I get that right. Welcome back, Sarah.
Yeah, thanks so much. Thanks for having me.
I feel like you've been on before, but it's just from the Healthy Buildings Conference that I got to know you a little bit.
Yeah.
You've had a big change here since then. You've moved on up to the University of Toronto. You got your PhD from Ohio State, and you're at the Department of Civil and Mineral Engineering at the University of Toronto. Let's start with how you became interested in healthy buildings.
Yeah, that's a great question. Yeah, so I'm really excited to be here. So with healthy buildings, I think for me it's something where this is where we spend so much of our time, right? I'm sure everyone talks about this on your show. We spend the majority of our time inside. So just thinking about how we're impacted by all of the different aspects and components of our indoor environment, be it microbes or chemicals or just outside air coming in. So for me, it was kind of an interesting start. So I started doing research in my undergraduate, and I had been interested in air quality, just in general, outdoor air quality. But then I started learning more about indoor air quality and how important that is, just to our health in general and to human health. And so I started looking into that, and that was really how I got more interested in it. But I think this is it's great that you guys have this going on and people are talking about it, because it's not something that people think about. They don't think about air quality in their house, right? We always think about air quality pollution, air pollution outside. So so it was that was really more how I got started into it, and how I became integrated in the community and with microbiome work as well. So really specifically getting into what kind of molds and fungus, bacteria that we're exposed to every day.
It's actually kind of a growing little community there, huh?
Mm-hmm.
You were at Ohio State there with Karen Dannemiller and her group. They do a lot of this kind of thing, and now you're at the University of Toronto. How did that end up working out for you there?
Yeah. So coming from, I think Canada actually has a really growing building science community. And so building science in the sense that they do have, they have people doing energy modeling and HVAC work and lots of that, but then also thinking about the health aspect and exposures. So coming to Toronto, Jeff Siegel is here, who I know you've had on the show before as well. And we had collaborated previously on some work. And so it's just a great community to move from. Obviously, I'm so grateful and thankful for my Ohio State group and everyone there, but then coming here and really starting to do my own research and get integrated with other people where we actually have a building science group. So there's 4 of us at University of Toronto in the civil and mineral engineering department who are focusing on building science as a whole, which is amazing.
It's absolutely amazing. It's seems to be growing all over the country, both here and in Canada. We're seeing more and more people focusing on the indoor environment, a lot recently too with COVID.
Yes. Yeah, that's what I think COVID has really brought it to the forefront of a lot of people's minds as well, even just in our communities, right? Just thinking about, this is something that we're all impacted by, and we've been spending so much time indoors and with our masks on, and I think it highlights a space where we need more people who understand building science and how buildings function, but also exposures and health indoors. And so that connection, I think COVID has really highlighted that we need more people who are looking into this and how important it is.
You may or may not know, but I'm just curious. Do you think there are more funding opportunities available now for indoor air quality type research?
I think I would say likely yes. It's just finding them, but at the same time, there are more funding opportunities. But everybody, I think a lot of people are on the train to do this kind of research, and everyone wanted to do COVID research, which makes a lot of sense. And of course, it was something truly important that we need to be doing research on, which is great. So I think there probably are more funding opportunities, and then also more people doing research.
So it's more competitive than
so
it
maybe
ever
more
was,
competitive,
huh?
yeah. But which is good though. I'm glad that people are looking into this and starting to focus on indoor air or indoor viruses. I think that this really highlighted, COVID has really highlighted how much we didn't know, or what systems that we needed in place ready to go if something like this occurs.
Well, I think it also pointed out the silos that we're in. The medical community is in their own little silo, and they've been following this 5 micron stuff forever. And they just wouldn't listen to a lot of the folks that were doing research on, aerosols and aerosol physics and and trying to explain that, hey, this is probably an aerosol issue, not
not
a
fomite,
fomite kind of thing. So it's been very interesting to watch.
Mm-hmm.
Now, you've been kind of, I wanted to get your perspective because you're kind of a young, new, upcoming professor in this area, assistant professor, associate, whatever they call you these days.
Assistant
okay. But you got involved with microbes in buildings and on carpet a while back, and we had talked to Karen Dannemiller about that. Let's talk a little bit about carpet and microbes and the research that you've done there.
Yeah. So I think it's kind of niche. I think we were with carpet. It's not something that a lot of people think about, like the carpet in their home and how is that. What are they exposed to with that? So the purpose was truly, when you have elevated moisture in your home, you get above 80% relative humidity, things start to grow. Fungus, bacteria, mainly molds, they're really happy. They love the moisture. And they can grow in your dust. And so I think that's really what it is. They're growing in dust in carpets. And we wanted to focus on carpet because a lot of the work previously was on drywall. Most people were looking at molds on drywall, and especially if you think about, in your shower, that's probably where most of the moisture in your house is coming from. Hopefully, if you don't have a flood, but you're showering, it's really hot and steamy, and things could be growing on your drywall. But with carpet, this is actually a lot of the times how we're exposed to microbes is through this resuspension of dust. So in the carpet, if the fungus is growing in your carpet in the dust, and then is resuspended, that's how you're exposed. And so that was really what we wanted to look at and actually create a model for growth. And so that's what we were doing. Well, initially, my project was I would go into people's homes and I would rip out their carpet and collect their dust, which was the funniest thing to be doing.
Hey, don't throw that carpet away. I need that.
Exactly. It would be like, oh, you're getting rid of your carpet. And I would drive up and take a big swatch and then leave. And so then, of course, the carpet people, I've talked to people later, they come in to replace the carpet and they're like, what did you do? What happened? But anyway, so I collected carpet from different people's homes and their dust. And we are actually trying to model how that growth was occurring over time and over a period of 2 weeks, depending on the relative humidity, because the moisture level in your home isn't going to be constant. It changes throughout the day, and especially depending on where you live, right? So like it's in San Francisco where things are pretty temperate compared to Florida. You have to really think about how moisture conditions are impacting our indoor environments. And I think that really brings us to like thinking about climate change as well, how the climate outside is changing. We're getting more floods and moisture. We need to be thinking about how moisture in our indoor environment can be causing increased growth.
And what just kind of generally, the paper, I think, is varying humidity increases emission of, oh no, that's the wrong one. Morphology and quantification of fungal growth in residential dust and carpet. Nastasi?
Yeah, Nastasi. I think he's
in building and environment. John, can you pull up a couple of the photos that we have from that? And maybe Sarah, you could go through these a little bit. Well, there's the paper.
Yeah, so so that's from a different paper. But if there's a picture of just fungus growing on, here, like those pictures there.
There you go.
So we were actually able to image, so Nick Nastasi was able to image the growth on the fibers. And what we were really seeing was when you had, obviously at higher relative humidity conditions, it's really clear here, I think, as you start to increase, so you're at 50%, that's the actual carpet fibers. There's some dust, you don't really see any growth. And then as we increase to 85, 90, there's some hyphae, and then 95, there's a whole spore chain.
Wow. And
then 100%, this image, it's more zoomed out, but there's lots of things going on. So you can really see, that's what could be occurring down in your carpet in your home if you're at these high moisture conditions. For I think these were incubated for days, potentially. I don't remember how long they were incubated for at these conditions, but what was really interesting was they're not really growing on or using, we weren't sure, were they using the fiber as some kind of source, like were the microbes and really like attaching to the fiber, and it was more the presence of dust was extremely important. So if there was dust on the fiber, they were able to grow, and they were there growing on these materials.
And, those are real high relative humidities, but I don't think people realize oftentimes that, when you've got a slab on grade, for instance, and that slab stays nice and cool, well, you get that elevated relative humidity at that, at that surface. And you could probably get in that 85, 90, 95% relative humidity range.
Yeah, because a lot of the times too, even if I think this is an issue that we need to start looking at and addressing, but a lot of the time the humidity in your home or, in a space says it's at one level. So you have the relative humidity monitor and it says it's at 60% humidity, but down at the carpet level, it could be a lot higher, especially if you've had a moisture event. So I think especially if you had flooding occurring on your carpet, people will try to remediate it. You have to remove the carpet. I would say there's not much you can do once it's wet, right?
Once that growth starts, it's tough to
get rid of that.
Do much with it.
Yeah,
I think it's pretty common, but there's always these questions about, well, how long has it been wet? And I don't know how long you incubated those samples there. Do you recall?
Yeah, so we were doing some work where truly we were looking at, I don't think that the images correspond to ours, but we were doing some quantification work where we would collect dust after a period of time. And it really was even after potentially 6 hours at an elevated moisture condition, you think that the microbes were active. They become active in the dust and they could start growing. So if this was over periods of days where you're up at, 5-10 days at a high humidity condition, you could start having this growth in your carpet. But we were looking initially at kind of it's a different paper, but varying relative humidity conditions. And if it was above 80% for even 6 hours, that could be an issue.
Huh.
Yeah.
So even that, we've always heard it takes 24 hours to 24 to 48 hours you have to dry things out and get it back to a point where it's not going to support growth. You're saying that could be maybe a little too long?
Yeah, potentially, because I think it's really thinking about just that they're active. So if they're just getting activated and if some kind of fluctuation continues, so even if it maybe for 18 hours it's at a drier condition, if it went back up to the high moisture condition, you could end up they could still be active. So this is something that I want to be looking into more in depthly, as well as getting this model of growth more situated, because we want to make sure, as you were saying, like how long does it take? How long does it take for really intense growth to occur? Yeah.
And you're talking about activated. How are you? That's a little different than just taking
that's true.
a sample and looking at it under a microscope. How are you determining when the genes have been activated?
Yeah, so for us, it was more of like this active or passive growth. So it would be they're active when they're like you said, like their genes are they're doing things. They may not be growing yet, so that might be the thing. So after 6 hours, maybe they're not growing, but they're excited, and if it continued, then they could start growing, and you could actually be exposed. But I think this is what you just brought up is something that I've been trying to look into, is actual gene expression of the microbes. So when they're expressing these genes, what is occurring and what level of moisture do you need? And I think we know we're seeing at 50, 85, 95%, even at 50%, things are happening that may not be they're growing, but they could be potentially releasing compounds. They could be there's lots of different things that they're doing, and we're still trying to figure that out. And all microbes are different, so it's difficult to determine, right? Because this one fungus may do this, but this other fungus may do that. Yeah.
And at this point, we're just talking about fungus, and there may be
Yes.
many other types of microbes involved as well.
Yeah, like bacteria as well. Yeah, there's actually really interesting the bacteria and fungal interactions, which I think we potentially need to be looking into more as well, because certain bacteria may release a compound to inhibit fungal growth, which potentially could be helpful for inhibiting fungal growth in your home. Like, so maybe there's microbes that are actually helpful and could be stopping harmful growth, like beneficial microorganisms.
Very interesting.
Yeah.
So first of all, what led to the interest in carpet? I mean, what made you guys think, hey, let's go check for microbes on carpet?
Yeah. So I think, it was initially Karen Dannemiller's work during her postdoc, but it came out of this paper that was specifically looking at growth on drywall. And so they were looking at growth on drywall. And then we started to think about, well, what about dust? What about other materials in your home? And so I think it was more, well, we know that we're exposed to dust more often than not. Like, if of anything that you're exposed to in your home, that resuspension of dust. And then thinking about, okay, well, where is that dust? Where's that dust home? And a lot of time it's in your carpet. There's so much dust loading in a carpet. If you're not vacuuming, a bunch of times a day, your carpet has a high dust loading. And so thinking about that, well, we know that there's microbes in dust. We know that microbes in dust can grow at moisture conditions. What about microbes in carpet? And so that was really key initially to start thinking about that. And then we started to branch out as well, not even just microbes in carpet, but emissions, chemical emissions, VOC, volatile organic compounds from the materials themselves.
Yeah, and that's really an important kind of a fork in the road here. You're looking at it's growing, but as it grows, what else happens? Do we have more VOCs? Do we have other issues that occur as it grows? So what are the main, I guess, takeaways so far from this carpet, work that you've been doing and others?
Yeah, so I think it really was that what we found was the type of carpet that you have in your home, the moisture condition, and the presence of dust. That was most important to potential growth in your home. So certain, I don't remember which ones. I think we looked at nylon and olefin. So it's common carpet types. So the type of carpet actually depending on the carpet type, it factored into how much growth was occurring and what was growing, and then the actual presence of dust. So having dust in your carpet was just a huge indicator of that's when you could have growth at these moisture conditions. But again, I do want to say, like, a lot of the research that we were doing was at these elevated conditions, and so your home hopefully is not getting to these high conditions all the time. But that's why we wanted to look at variations in humidity.
And, how does this relate to IAQ practice? For those of us out here trying to do this work, I mean, I've got some thoughts on how it relates, but I want to get your thoughts on how it relates for people out here doing water damage restoration or mold remediation or mold inspections, indoor air quality inspections.
Right. Yeah. So with the carpet, I think specifically with the carpet, I think what we were finding, at these elevated conditions, if it is such a short period of time, potentially that the microbes could be as we were saying, like, become activated, potentially start growing. Maybe then we need to start looking at how are we remediating sooner than later, or also just, if you have a flood and you're trying to remediate and there's carpet in a basement, which most people put carpet in their basement, which is likely where any kind of moisture damage is going to occur. Just thinking about that needs to be removed. I think that was one of the main things that I learned just through all of this research, maybe not just from the paper, but that there's not much you can do. Once the carpet is wet, there's only so much you can do. Remove it and start new, right? Like I don't think that we can, and that maybe that's another area of research that we need to get into, is thinking about how you're either like vacuuming up, suctioning up water from the material themselves. Yep. And is there something that we could be doing in that sense, and it actually inhibits growth afterwards?
Interesting. Cliff, you got a follow-up?
Yeah. Actually, a couple of, I'm looking above your head and I can see the ceiling tiles, and I've also got them above my head. And you were talking about equilibrium, relative humidity, and high humidity conditions, and so on and so forth. Above you, there's probably pipes for air conditioning and so on and so forth. And all you need is a little drip.
Yeah.
And, when that water hits that carpet tile, you're going to have a microclimate, and it's going to, you're going to have water activity.
Yeah.
And this mold can grow anywhere. It doesn't have to have a flood. You don't have to have really high humidity. I mean, anywhere that you've got a leak. I guess the second point is really, I know you're studying the carpet, I know you're studying the fibers, and you could really see the difference between your nylon fiber, how smooth it is, compared to the wool fiber, which is really scary, scaly. But these carpets have backings on them. And it's that backing that comes in contact directly with the moisture. The moisture's going to hit the back of the carpet before it ever hits the fiber. And those fibers can't really hold it. They can only hold I think polyester, 2-3% or less than that in moisture. Wool can hold a lot, but a lot of it, I think, is the backing and the role that the backing plays. And there are different types of backing. I mean, years ago, when I first entered the industry in the 70s, the backings were natural. It was all jute, which was on the back of the carpet. So I think it would have been way worse there. I think there have been some improvements, but I think a lot of these wool carpets, you need to be careful. What's the backing material?
What's the backing? Yeah, I think that's actually such a good point. And it was something that we wanted to, in this study, we were wanting to look at, but it's how do you determine the growth on the back of the carpet? So that might be something to look into more, because I agree. I definitely had, when we were doing these incubation studies, just had the carpet in there. Certain carpets that were really dirty, maybe from a space that hadn't been cleaned in a while, there was mold on the back of the carpet growing, for sure. And it wasn't even that it was just in a humidity condition. It's not like the carpet was wet initially when I put it in there. I wish I had the pictures there. It's just covered. So I think that's super important point to bring up, that the back of the carpet, what are we using? What materials is the back of the carpet?
Well, when you think about it, you're talking about particles, and Joe mentioned, 5 micron particles, then particles less than 2.5. If you think of that carpet as a filter, the finest of the fine particles are going to end up going down through that carpet, and they're going to go into the backing, and they're going to go underneath. So you probably, if you've got stuff going on in the fibers on top, you probably have a zoo or whatever going on underneath.
Yeah. And how do you get in, if you're trying to vacuum it up, how are you going to get that off? If it's in the back or underneath, you're not getting it up. Yeah.
And I want to get on to your other papers here after halftime. But before we get to halftime, there was a question here about, and I had mentioned VOCs. What about mycotoxins? Did you look at the mycotoxin production at different relative humidity levels?
So I don't believe, I'd have to double check the other paper, but that's not something that I've been doing. But I think that is really important to start to look at the actual mycotoxins, and then even allergens as well. That are coming from the material. So that's kind of what we were hoping to do with the MVOC work. And so we're just still working through some of the data. So it's the actual microbial volatile organic compounds that are being released. And that goes hand in hand with those mycotoxins, and thinking about the gene expression there of the fungus in the dust.
And then the big question becomes, how important is this with respect to health? And I don't know that that's been answered. I'm just kind of throwing it out. Is that where you're headed? Is with this kind of research?
Yeah, and I think absolutely. Like thinking about the human health exposures, because all of this, it's interesting work, but when we think about putting it, as you said, like putting it into practice, how are we going to build a better, healthy, equitable, sustainable indoor environment? I think directly, like anything that is giving off emissions or there's molds, allergens in the air, that's directly a human exposure, right? So, and yeah, so I think that's how it relates to health immediately. So it's something that I would like to start looking into more, doing more, potentially working with people in public health or in medicine, as you said, because they're always so separate. We need to start some, more collaborative work, at least with myself, looking at collaborating with other people. And
got to get out of those silos, huh?
Yeah, right. It's easy. Yeah, it's easy to happen.
All right. Hey, we've got to stop and thank our sponsors real quick. We'll be back in 90 seconds with Dr. Sarah Haines. Having a good time. Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org, ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science, ACGIH.org, the Cleaning Industry Research Institute. See more deeply through science and research, CIRI science.org. The Indoor Air Quality Association, IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, restorationindustry.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Healthy Buildings America, Honolulu, Hawaii, January 18 through 20, 2022. HB 2021-America.org. Industry sponsors are AEML Laboratories. Free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring. GrayWolfSensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations. TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back the second half with Dr. Sarah Haines. Sarah, there's another paper I wanted to get to here. It's called, let me get it right here. Varying humidity increases emissions of volatile nitrogen-containing compounds from building materials. This was in Building and Environment. And it looks like you were looking at emissions from, I'm not sure, was this from 2x4s or structural members or what?
We're still on carpet. It was still carpet and dust and then drywall.
Oh,
okay. Included drywall. Yeah.
I think we had a picture. I don't know if it's from that paper.
Yeah, it is. Yeah.
John, there you go. That's the one, John. Pull that up. Wait, man, I have to maximize my screen here.
Yeah.
There we go. Tell us what we're looking at here, Sarah. Yeah, so this is a PTR-TOF MS. So it's a proton transfer
time of flight mass spectrum, but basically what it's doing, it's really awesome technology. So it takes air, it's flushing the air through those little jars. So we have little jars, glass jars with the actual sample. And so within those glass jars are carpet. We have pieces of carpet that we cut up, and then on the right, there's some drywall. And then on the carpet, I think we either had it just plain carpet, or we put some dust, sprinkled and embedded some dust on them. And so what's happening in these jars is that air is being flushed through and then sucked back out. And you can kind of see on those little graphs on the computer monitor, but it's actually measuring emissions in real time. So it can actually determine what VOCs are coming off, and it gives you basically gives you a mass ratio of the chemical emissions. But then you can go and determine what chemical compounds are coming off at real time. So what we were able to do was different humidity conditions, and this actually would regulate the humidity. So we had them getting sniffed, is what they call it. They're being sniffed for the VOCs at different humidity conditions as well, which was great. So it was super interesting. This was actually at UC Berkeley. We were using some equipment there. But yeah, so what we were, oh yeah, go ahead, sorry.
Well, I was just going to say, so you're looking at, and John, could you put the paper up real quick? Because I think just sometimes in looking at the title and the wording you use helps me to get the practitioner group to understand better what you researchers are looking at. And what threw me here is you called it volatile nitrogen containing compounds. We're normally used to seeing volatile organic compounds. Why this little bit of a tweak in the language, Sarah?
Yeah, so we were looking at the volatile organic compounds coming from the building materials themselves, but what we found was that actually varying humidity conditions, so fluctuating the humidity between 50 or 85, I believe it was 50 and 85 was our main fluctuation, that there were more nitrogen containing compounds coming off of the building materials than if you just left it at, say, 85% for a week, and you measured the emissions coming off. There weren't as many nitrogen containing compounds, but when you started fluctuating them, then there was this increase, which we're not really sure why, but it was just extremely interesting to see these types of these specific compounds that for some reason changing the humidity actually it changes the composition. And so fluctuating it, you actually ended up with more of these types of compounds.
And how would that, I'm not saying for certain, but with respect to health, how would that be important?
Yeah, so I think just thinking about what compounds that we're more likely to be exposed to on a day-to-day basis. So we were really trying to do something where this is more similar to variations that you would experience throughout your day. And obviously we can't get it 100% what you in your home, variations in humidity, but if we're thinking about what you're actually exposed to all day, you're not just sitting in a room at 85% relative humidity. It's changing all the time, especially with temperature. So with this, if we're starting to determine compounds, very specific compounds that are coming off more likely in your home on a day-to-day basis, I'm not 100% positive what nitrogen, if we know specifically what nitrogen containing compounds could do to health, but I think looking into that more and really narrowing down these exposures is important.
I think it also illustrates really nicely how unbelievably complicated this whole topic is.
Yeah, right?
I mean, it's like, my goodness, here we are thinking, okay, VOCs, and people don't realize when you get a sample for VOCs, you might get 300 different compounds you're looking at here. How do we decide which ones are the important ones because ultimately we're looking at health. I mean, that's what we've got to ultimately look at. So you've got your work cut out for you.
I know. Yeah. I think that you're absolutely right. Thinking about how which VOCs, and I think I do mostly microbes. So, the people out there who are doing more chemical indoor air quality, they may be like screaming right now, like it's these ones. But I think, really thinking about what we wanted to do here was integrate those microbes and chemicals, because we kind of, as I just said, like we think of them as separate, like, okay, I work on microbes, then someone else works on chemicals, but there's so much going on and there's so many different aspects. It's possible that the microbes they could be using the VOCs that are coming off of or something's happening to them from the compounds coming off the carpet or the material themselves, right? We just don't know. And then how is that impacting our health, because maybe the microbes are then doing something else that they wouldn't have done. It's activating some other gene, right? Yeah, it's very complicated.
Very. And then you go into the individual person's, susceptibilities or sensitivities or whatever. It makes this all very, very difficult to really, tease out what is actually causing that issue for that person. Is it the spores? Is it the VOCs? Is it the mycotoxins, the beta glucan? I mean, you all have your work cut out for you here, Sarah. you won't run out of things to look at.
I know.
So from that particular topic, that particular paper, what are the main takeaways from that paper?
Yeah, so I think it really was that varying humidity conditions and different humidities and moisture cause the release of different VOC. And so it's hard to say, this is the makeup of VOCs in your home, because maybe it would be, or in a building, because maybe it'll be different depending on all like the temperature and the humidity. So I think it's really just focusing on elucidating all those different aspects, and now we can start thinking about more, how is moisture impacting release of compounds just from materials themselves.
Before we talked, I didn't even it never really occurred to me. So you have to get a background of what VOCs are coming from the carpet itself, then what different VOCs or maybe increased VOCs are coming from the carpet after it's been exposed to relative humidity. And it seems to me like what you're trying to do, and other researchers, is kind of build us a background, like, okay, this is what we see in the carpet before anything happens to it. This is what we see after it happens. And this maybe will help us understand a little better what the potential for health effects are.
Absolutely. Yep.
And then taking another step, how do we remediate that? Maybe removing the carpet isn't always the best thing. I don't know. Maybe there's ways of cleaning it a little bit better, but very interesting. All right, let's go to the next paper, John. This is another interesting one. We have, let me see if I can find it in my notes. Oh boy, I can't pronounce this one too good here, Sarah. Let's see. Vishnia Cosima Victoria, Cryptococcus Victoria in the homes of asthmatic and non-asthmatic children in New York City. This was in the Journal of Exposure Science and Environmental Epidemiology. So give us a little idea of why you did this to start with. What led to the interest in this particular issue?
Yeah. So this is a really great collaboration with Rachel Rush and then Brett Green, who were at NIOSH in West Virginia University. But so I think the real purpose of this was, a lot of the times we think about how these microbes, and we've been talking about it, are impacting our health in negative ways, right? But there are still potentially beneficial microbes. And we see that, I'm thinking of, there's one specific study where they were looking at children who grew up on farms, and in their homes in a farm where they grew up, they were less likely to have asthma than children who didn't grow up in farms. And I think that was done in Finland. And so, thinking about how exposure to certain microbes may actually have beneficial effects to preventing, or preventative effects to asthma or allergens in children. And so with this, we were looking at this Vishnia Cosima V. Victoria. I'm just going to say V. Victoriae, so we don't have to keep trying
Thank
to
you.
say that. But it was a Cryptococcus. Previously, it was Cryptococcus Victoria. They renamed it. But it's this yeast that we see very prevalent in indoor environments. And so they had previously found that yeast can have these kind of preventative or effects on asthma. And so we wanted to specifically look at this. No one had actually looked at this yeast species before. And so I think it was like 250 homes of children with asthma collecting dust, and then looking at the presence of V. Victoriae, and if there was any relationship between their asthma and asthma prevalence and then the prevalence of this species.
And what did you find?
Yeah, so we actually did find that when then the V. Victoriae was more abundant in a home, it was less likely that the child had asthma or had, yeah.
And where does this come from?
The V. Victoriae?
Yeah.
That's a good question. I'm not sure where if it's coming from outdoor or if it's just I would assume most of our microbes inside, right, are coming from something tracked in from outdoor air or from us. I mean, I don't believe that it's a human, because it's non-pathogenic. So yeah, it just potentially has this protective effect. I mean, this is all association, so we can't say, oh yes, you need to be exposed to this yeast, but it has these potential preventative effects with repeated exposure to the organism.
It says here, moreover, our data suggests that V. Victoria is associated with the dog microbiome and
provides
I forgot
about that. Yes. Yeah, that was really interesting. Dogs. Yes, absolutely.
I remember we had, I think it was Jeff, or it might have been from Yale.
Jordan Pescia. Yeah.
Jordan Pescia. He was saying, hey, yeah, that's it. Get a dog, for your young child, and expose them to a few things, and this must have been one of those things. Yeah, looks like it's from the dog.
Good. Yeah.
So, all right, what can IAQ practitioners take from this?
Yeah, so I think it's more of just thinking as a whole of maybe we don't want to continuously be getting rid of microbes in our homes. And so I've been thinking about this a lot with COVID, right? I think we all went through, I know I did, where I was just spraying everything with Clorox in my house, and you want to make sure you get rid of everything. But we need to really be more mindful of this thought of, oh, we need to get rid of all the microbes in our house, and get rid of anything, because some of them, like this, could be potentially helpful. And I mean, like you said, dogs have so many different dogs, cats, like they have so many different microbiome. I think that, and I think it's difficult though, right? Because if we're actually going to put this into practice, how do we differentiate? Okay, we're going to get rid of this harmful organism, but not this helpful organism.
Right.
So maybe that's a next step of trying to figure out, is there a way to promote, or what are the truly beneficial microorganisms in our indoor environments, in our homes? And then how do we promote them, but also get rid of anything harmful? So I'm not sure if that's if there's putting into practice in a way, or just kind of start thinking about this idea more. That we don't
something to keep in the back of your mind for sure.
Yeah.
What about, okay, so how did you measure this V. Victoria?
Yeah, so it was
dust samples?
Yeah, it was in dust. So it was dust, and I believe it was just DNA, extracted DNA, and then we quantified it via real-time PCR. So it's just a quantification, using qPCR, I believe.
You've been doing a lot with dust, and I think what we're going to do is we're going to go to the Roundup, and then when we come back, I'd like to go into some of the stuff you're working on now.
Great.
So we'll be back in just a second with Dr. Sarah Haines. We're having a good time talking about what did we end up calling
Carpet
this?
and dust.
The puzzle of buildings and health. We'll be right back. The Roundup is brought to you by AQradio, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. AQradio, healthy air, healthy home at aire.com. All right, let's talk. I think currently you're looking at some projects. You're deploying air filters in classrooms, and then you're going to do some filter forensics. And I remember on the show with Jeff Siegel, he was doing filter forensics on, I think it was home HVAC system filters, where he was cutting out, a piece of it, looking at what was in there. What are you looking at here now?
Yeah, so these are just individual air filters that can just be placed in a room, in a building. It's easier to transport. And then we have filters. We have filter paper that go in the filters. And so we will be running them, collecting dust, vacuuming the dust off, and then using the dust to quantify and just detect. Our initial hope was to look for SARS-CoV-2, just to see if it's present in a classroom on campus or in a building. Now we have all of at U of T, you have to be vaccinated to attend university or work on campus, and you have to wear a mask. So potentially we're not going to find anything, which would be great, right? If we don't find anything,
sure,
that means nobody's being exposed. But the initial study was to look at and think about, can we detect it, and can we use this to monitor, and then potentially using it to monitor other viruses or bacteria, fungus specific organisms potentially, or just overall in a room. And so so there's the picture. These are the actual filters. So it's just this I believe it's like cellulose filter paper. And then those, we just did tests in our own different homes. And so you can actually see after a couple weeks. And then these are the actual filters. So we haven't deployed them yet. We're hoping to get that going soon. But yeah, those are the filters. So they're pretty small. They're about that. Yay.
How is the air pulled through there, or is it just passive?
No, it has a flow. I forget, we tested all of it, so I don't remember how what the flow rate was, but it was actually fairly decent, because that was the worry. Would we actually be getting, how much dust is actually going to accumulate on there? But I don't remember what the flow rate was, but it was pretty good to actually suck the dust and anything in the air onto the filter.
Well, you're doing a lot of dust collection and on filters. It seems like that's been something that we see a little more of in the indoor air quality world too. I know people, for years, like Joe Spurgeon and others have been, it's about the dust. You got to look at the dust. There's different ways of looking at the dust. Yeah. Does that seem to be a trend in the academia that and I think it's partially because you can do this, PCR and all this analysis that we can't really, many homeowners can't afford to do.
No.
Is that kind of a trend in academia right now?
Yeah, I think a lot of people were thinking about using dust as this matrix. And I think it's important to also think about the bulk floor dust, so things vacuumed up from the floor in your vacuum, versus these filters, which would be what was in the air more likely. So there's difference. And I think both are super valuable to be looking at. Well, what was aerosolized, what was an aerosol, and then what's down in the carpet or on your floor in this bulk dust. But yeah, I think that you're right, using dust, because we have these quantitative methods that we can easily use, which potentially I think is really important as the technology moves forward. Could this be something that we could be doing in individual homes? I know I talked to somebody about how we do the genetic testing, or you get the 23andMe swab and you figure out what what that, or you have ones where you can figure out your microbiome. Maybe we could do that for a home as well. And as the technology progresses, I think it's possible that we could be having these maybe quicker means of getting quantities of microorganisms in your house. Yeah.
Interesting. What else are you working on right now, Sarah?
Yeah, so I've been working on this project, and then as well as a gene expression work that kind of carried over from my PhD, where we're actually looking at the relationship between MVOCs, so the microbes released, the microbial volatile organic compounds, the odors, and then the actual gene expression of the fungal organism. So we've been really working on trying to figure out what genes are being expressed at those moisture conditions. So that's what I have been working on lately. Yeah.
For some of us non-academics here, I play one on the radio here and there, but I'm just curious, explain to our listeners why understanding the gene expression is so important.
Yeah, so I think that really lends itself directly to human health. And I think somebody put it up in the chat, like we were talking about, like the mycotoxins.
Yes.
So thinking about what they're actually doing, what genes they're releasing, what are the microbes actually doing at these high humidity levels to then potentially be releasing this compound or releasing or doing something else that could potentially come into contact with us and have a negative health effect. Or potentially a positive health effect as the V. Victoriae, where it might have something where this could be protective or, yeah.
Right. And that gene expression helps you understand that. Yeah,
it helps us understand what they're actually doing. So we know, we can know that they're growing, but like what are their actual functions? What kinds of things? So we're trying to connect the MVOCs and the gene expression. Hopefully that works, but we're still working on that. It's a difficult connection.
You're talking about the gene expression within that organism. What about what gene expression that would elicit in people? You know what I mean? If you're exposed to these MVOCs, what does that do within us?
That's a good, and that's we probably need somebody who's a doctor, a medical doctor to or someone who does people, because that's a really good point. Like what exposure to the MVOCs, what kind of, is it impacting anything that our bodies do or something in us? I'm not sure. I don't have the answer to that, but I think that's really important to think about.
Seems like a next step.
Definitely a next step.
This background on the expression within the organism itself. Now, how does that gene expression affect the gene expression in other people, animals, etc.?
Yeah.
Interesting. Very interesting, Sarah. Very interesting. All right. Anything else you're working on before we wrap it up?
I'm hopefully working with some communities in Toronto and just in Ontario in general, hoping to work with First Nation communities who are impacted by lots of mold and moisture issues. So that's next step, but it's all in the works right now since I just started in July.
I understand. Yeah, you've
I got a lot of work to do.
Plus, you have to teach a couple classes, I assume.
Yeah, I start teaching in January. Yep.
And this is a week. What week is this? Book reading week or something?
Oh yes, it's reading week. It's University of Toronto's reading week. So
how does that work?
There's no classes this week, so students had a week off from classes, and then it's nice for them. So then we didn't have to teach this week, and then they'll usually, I think some professors have exams after, but you're not supposed to.
So are they supposed to be reading a particular book or just
no? They're just supposed to be working on their studies. We didn't all have to read a book. That would have been interesting though.
Yeah, that would be. I wonder how many of them took reading week and did things like I did last night. I don't know.
Somebody put in the chat. They said it's reading week in all colleges. Oh, so it's everybody.
Oh, all of Ontario. Thank you, Dawn.
Thank you.
All right. Well, Sarah, before we go, thanks for joining us. It was great.
Thanks so much.
love having the young up and coming academics on the show here, and then trying to get them to, relate a little more to our practitioner audience. So we really appreciate it. Before we go, is there anything you'd like to add?
Oh, that's it. Thank you so much. It was really fun. Great to talk to you all.
All right, Cliff, before I go, I'm sorry, Cliff, did you have anything you wanted to add? Any follow-ups?
Yeah, I was just, when I heard the word cryptococcus, it really scared me.
That's fair. Some of them are terrible.
Yeah, the neoformans, the one that comes from pigeons and stuff, is really nasty. And Joe and I know all about that because we actually wrote a paper about it. Yeah, absolutely. So that was a nasty one. But
remediation of pigeon feces is not my. I'm sorry, but I try and get young people to understand this is not something you want to do for the rest of your life. It's just not. Going up into a bell tower on scaffolding that's 40 feet in the air and cleaning up pigeon crap is just, I don't know.
But you could eat off the surfaces after we remediate it.
Yes, you could.
Sure. Yes, you could.
Well, Sarah, thank you so much again for joining us. We really appreciate it. I want to say thanks to our guest. I want to say thanks to the Z-Man. To John, you got to have faith at the controls. Don't forget to go to afterthoughts.iaqradio.com. We'll be throwing up we'll have the blog up there eventually, but we'll be putting some papers up there and whatever we can. And then we're going to have a little discussion after the show. We put a copy of the chat from today. So looking forward to it. Next week, we've got Dr. Richard Corsi. Looking forward to that. Rich was our original research to practice. Like he was our guy, our go-to guy. And then he got real important and moved on up to Portland State. And now he's back at, down in Cal. Yeah. So we're looking forward to getting back together with Richard and talking a little bit about research to practice. So we'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.